Yeah? Okay, guys, are you ready? Oh, it's loud. I have to speak slowly. Um, so good afternoon. I don't speak Hebrew like the former speaker, so you will have to do with English with a strong French accent. That's all I can do. Or I can do French also, but it's not super helpful. So thank you for attending this session on hybrid architectures. I know you had a lot of presentations today already. You must be tired. You're almost there, though. You're almost done. I hope it's been a good day for you, that you learned a lot on AWS. And so in this session, we're going to talk about hybrid architectures. So my name is Jean-Pierre Le Goalet. I'm a senior manager and solutions architect at Amazon. Been at AWS for about 4 years. Before that, I was in the US working for a startup and working for Oracle and Teradata. And before we had the office in Tel Aviv for Amazon, I used to come pretty often here. Now, unfortunately, they don't need us anymore, but which is good for the local market, of course. So what we're going to talk about today, that's kind of the outline of the presentation. We'll start with an introduction on hybrid architectures. Then we'll look at connectivity, which is an essential part of any hybrid architecture. We'll look at how, if you have established operations on premises or in your own data centers, what is the impact of AWS on these operations? How to modify your operational processes to integrate AWS. Then we look at common workloads or common examples of hybrid architectures. And finally, we look at how to migrate applications from on-premises to AWS. So why the cloud and why hybrid? By the way, I'd like to get a feel for what do you guys do? So I'd like to understand who works in an enterprise, a large company? Who works for maybe government? No, many. Yes, startups. Who has on-premises infrastructure? Quite a bit. Okay, so that's a good audience. Okay, good. If you're fully cloud already, this could be a bit less interesting, but otherwise it should be. Hopefully, it's be good. So why the cloud and why hybrid? So different answers, and I will keep it short. But I started with this quote: "In the new world, it's not the big fish, which it's the small fish." It's the fast fish, it's the slow fish, right? So we see a lot of, especially in Israel, a lot of disruptive startups that are moving very, very fast and that are disrupting larger players. AWS itself is disrupting larger or more established enterprise hardware and software providers. So speed and agility matters. You want to be the fast fish, so speed and agility matters. And why the cloud is not by itself doesn't give you speed. It helps you to be faster. So you can have access to infrastructure, of course, very quickly, be it computing or storage, but also you gain time by leveraging all the managed services that we have, such as it's easier to provision an ELB, Amazon Elastic Load Balancing, than to install your own load balancer, for example. Or you gain time if you use managed databases like RDS or DynamoDB versus managing your own databases. So that helps with your speed and your agility. It helps you also focus on your business as opposed to focusing on procurement of hardware and software infrastructure. And finally, just to summarize, cost is also important, obviously. So we reduce our cost frequently, and we never increased them so far. And more importantly, the customers see the benefit in terms of total cost of ownership of AWS versus on-premises. So that's another key aspect why existing enterprise or customers like you that have on-premises infrastructure are looking increasingly at adopting the AWS cloud. So that's an example. Samsung in the first 2 years saved $34 million. Of course, they're big, so if you're small, you won't save as much. But it's an indication of the return on investment they had in just 2 years. And typically, what the TCO study says also is that the savings increase over time. And we'll see a bit why that is. So this is a quote that I like from Charles Phillips, who is the CEO of Infor and the former president of Oracle. So friends don't let friends build data centers anymore. Why? Because it's just a lot of expenses. And it's probably not the best usage. In most cases, it can be the right thing for some customers. In most cases, it's not the best usage of your capital. But maybe you already invested millions, for example, or maybe not millions, but a large amount of money in data centers, and that's fine. Because there are more than two choices, right? So one would be build a private cloud and stick to that, or throw everything out and move to AWS, which will not be reasonable if you have large existing investments, right? So the solution is, well, in this case, is to start with hybrid architectures where you integrate on-premise resources with cloud resources, and that's the topic of this presentation. Just to finish the introduction, quick definition by Gartner of hybrid architectures. So it's a result of combining internal and external services, usually from a combination of internal and public clouds. So today, again, we look at some hybrid workloads that are very commonly used, especially as a first use case for companies that don't yet have cloud deployments. But before that, we look at how the cloud will impact your operations. We start with connectivity and networking. We move on to security and compliance. I understand you just had a presentation on security, so that should be very familiar. How to integrate the new processes that are that you need to adopt to manage your cloud environments into your operations. And finally, we will talk actually pretty briefly in this session about how to manage your accounts from cost and billing perspective. So I've been working with a large enterprise where in their case, they're moving all in to the cloud at that decision. And we did workshops. So we did one-day workshop on all of these. So that's probably a good start. And we will see, I will give you some pointers of what you can cover within these workshops. But we started with a one-day workshop on each of these topics. And then they started agile sprints. In that case, it's a 2-month sprint. It's 4 sprints, 4 2-week sprints, or 2 months, where they want to totally understand the impact on their operations. In parallel, they're doing a proof of concept on AWS. So we'll see that a lot of process stuff. That doesn't mean you should wait and not do anything until you've fully understood all the impact on your processes. That's really not the goal, so I hope I don't come across that way. But you could do that in parallel. So let's start with connectivity, which is probably networking and connectivity are typically the first challenge that you need to address. So you have your existing on-premises infrastructure. You have I have 2 screens to look at. And you have your AWS resources, so you want to connect. The easiest way is to connect them over the internet, over a VPN. So we provide a virtual private network service. So on our end here, we will you can provision, just click of a button, a virtual private gateway. So it's actually a redundant VPN tunnel across 2 different availability zones or data centers. And you can connect that to your data center to a router. Ideally, that will support that has to support IPsec encryption, and ideally that will also support BGP, Border Gateway Protocol, in order to have a highly available VPN connection to AWS. So this router can be like a Cisco or Juniper router. We list the models on the website. It can also be an open source. It can be a Linux server with open source IPsec and open source BGP running on it. Doesn't have to, and you want to have 2 that ideally for high availability. So that's the first solution. The second solution is to have your private connection. So some customers tell us we want to have a very low and predictable latency, and we want to have predictable throughputs. So the private connection will not give you more throughput than the internet. The internet has infinite throughput pretty much, but it will give you something stable. So to do that, we have a service called Direct Connect that allows you to connect your network to ours through a direct connect location. So you cannot connect straight into our data centers, but we have partners that operate, such as Equinix, that operate data centers that are very close physically to our data centers. So you ask a telco, and might be a bit pricey from Israel, but you ask a telco to provide you a dedicated line from your data centers to this location. Can be in Frankfurt or can be in Dublin, for example. And then from here, we already connected to them, and they will cross-connect your network with ours, so you have an end-to-end dedicated connection, which can be 1 gigabit per second, 10 gigabit per second, or several increments of that. You can also have smaller bandwidth, starting at 50 megabit per second, by going through a direct connect partner. Using that direct connect, you can connect your data center to multiple VPCs, multiple accounts, if need be, on AWS. And by the way, ask me, I'm going through the slides pretty fast, so I see you, sometimes you're taking pictures, and by the time you take it, I already moved on. So ask me for the slides, I'll be happy to share them after. And you can connect also we have some global customers like Schneider Electric, which is a French company, integrating with multiple regions worldwide, and basically bringing AWS as one of their data centers in their worldwide network. But that would be for a global company. So that was the networking part. Again, I advise to have a networking workshop when you start, and then identify how you want to do that. So let's talk about operations, how you integrate operations in your processes, and we'll start with security and compliance from a process point of view. So I hope there won't be too much redundancy with the previous session. So first, we probably talked about this. We have all these compliance certifications that usually help with our first conversation with security team. Another advice, if you work in a large organization, you probably have a security team, is to involve your security team as soon as possible in the process, so that they can be part of the solution as opposed to trying to mitigate a problem later down the road. So this helps typically when we tell them we ISO 27001 certified, ISO 9001. We have SOC 1, SOC 2, SOC 3 reports that we can share under NDA with you guys. So that typically helps for compliance. For security, you're going to have to do a security design for AWS to adapt your processes to the specificities of AWS and of the cloud. So we're going to go through the different categories and see how we can leverage some of the AWS services to accomplish this. So the first one, logical access control. So now you don't have to bother to worry about physical access to your resources, right, in the cloud. And we don't let people come in and touch them. So all access now is logical, right? So we need to lock that down. So there are different ways. One of the ways to use a service called Identity and Access Management, which allows you to create users within your account and gives them a set of privileges that they need. And typically, it's as little as they need to do their jobs, right? You can also define roles. Roles are also a set of privileges that you can assign to in AWS service, for example, an EC2 instance, or you can assign to someone within an account or within a different account. You have to decide, how you're going to lock down access or restrict access to the AWS Management Console. If you're going to enforce multi-factor authentication, how you're going to manage your keys, your IAM keys. So when you create an IAM user, you can generate an access key and a secret key. With that key, the users can issue API calls. You want to restrict that as much as possible. You want to rotate your keys every few months, ideally, so that's part of the process to define. And finally, if you have an existing Active Directory or LDAP identity management system on site, typically you don't want to replicate, you want to integrate with what you have already. So that's an example where you have an Active Directory domain controller on site, and you can set up Active Directory read-only domain controllers on AWS that read permissions information from the main controller, so you don't duplicate the information. Another example is we have a service called AWS Directory Service, which acts, it can work as a standalone directory, but it can also work as an AD connector or a proxy to your on-premises Active Directory. And you can use this today to authenticate your users to the AWS Management Console, to several AWS applications such as Workdocs, Workspaces, and Workmail, and also to the AWS Management Console. I had said that already, sorry. And to EC2 instances running on Windows. It doesn't work yet with EC2 Linux instances. And finally, if you already have an identity provider that you use that is SAML 2.0 compliant, you can just integrate it with AWS very easily. And this way you can associate, you can give your users in-house, you can give them, associate them to roles, map them to IAM roles to give them permission to accomplish certain tasks. For example, the ability to launch a CloudFormation stack or to launch an instance. Account structure, so that's another interesting topic where you typically, people who start with AWS, they have one account and they do everything in that account. And what we see is when we work with large enterprise, they prefer to lock that down a bit more. So they create multiple accounts. And actually I have a picture after that might help. So they will create, so you have your root accounts, right? And they might use it just as a main account, or they might use it as an account which is going to create IAM users in a different account because they want to restrict access to that account as little as possible because this is root. This has all the power to do anything on AWS. So they will create their IAM users in a different account, and they will create roles. So roles are again IAM entities, IAM sets of privileges. They will create roles in different accounts. So the accounts that have resources here, development, test, and production, will not have users. Nobody will be able to log on straight to them. They will only have resources. They will have EC2 instances, databases, etc., workloads running on them, but no user. The users will be defined in a separate account and can assume a role to perform a task in dev or in prod. That's a way to mitigate the impact if somebody, like a user here, was to post their access and secret key on GitHub, which happens all the time. In this customer I was mentioning before, I had a workshop with them. I told them, never put your access keys or secret keys on GitHub. And 2 weeks later, guess what? One of them that was in the class put his keys on GitHub by accident, of course. He didn't mean to, but that happens. So that's a way to lock down and mitigate the risk of exposing your access keys and on GitHub, right? Typically, we actually monitor GitHub for access keys and secret keys ourselves, and typically find out before our customers, and we mitigate the issue. Well, at least we'll inform you and typically help you, mitigate the problem. They will create roles also for financial controllers. There's no reason for somebody in finance to have an account really on AWS. They just want to look at the bill, right? So we just create a role so they can view the bill. And then they create also a dedicated security account where we're going to send all the logs. So you probably heard of CloudTrail, which is a service that logs all API calls made against AWS. And you can send all your CloudTrail logs from all these accounts. That doesn't work. Okay. From all these accounts here and consolidate them into one account. And only security has access to that account. Potentially, if you are audited, depending on your industry, you could grant read-only access to your auditors to that account also. This is not the truth. This is not the only way of doing it. It's just a possible way of doing it. And you probably will adjust that to your own needs. So, sorry, I missed the picture. You want the second shot? Again, if you ask me, if you come after, I'm happy to share the slides. There's nothing confidential here. Network configuration. That's also we talked about network connectivity, at high level. You also want to lock that down and secure that as much as possible. So we talked about VPC, VPN. If you do a direct connect connection, direct connect is not encrypted. So you want to make sure you either force encryption via using SSL or HTTPS over the line, or to encrypt this direct connect also through a VPN. In VPC, we have you create subnets. You can create network access control list on your subnets that allow you to allow traffic, or just as importantly, deny traffic. You can blacklist IP addresses or range of IP addresses with knuckles, which is very important if you were to have a DDoS, for example, against your infrastructure. And then you need to establish best practices for standard security components, network security components such as routing tables, security groups, and maybe allow your users to connect straight to AWS servers, or ask them to go to a Bastion host. Bastion host is like a jump server. You log on first to the Bastion host if you need to do administration work on the environment. as opposed to SSHing or doing RDP straight to a host. The advantage of this is when no admin work needs to be done, you shut it down, and nobody or no one can connect to your servers. It will be, you could do both. Traditionally, it's per VPC, but now we support VPC peering. You could do it in one VPC and jump to another one. Data encryption, of course, you probably talked about this in the previous session. It's very important. We have different services that allow you to encrypt your services. In this case, we manage the keys. In this case, in the second, so with key management service, we manage the keys. With Cloud HSM, you manage the keys. You will also define policies for data in flight, such as using SSL, SFTP, FTPS, etc. And finally, some tiering, because typically you don't need to enforce the highest security level and encryption for all the environments and all the applications, right? So ideally, you should be able to whitelist, approve a few services that don't need the utmost security, so your team, your enterprise can get started with AWS before everything is defined. Asset configuration, CMDB, configuration management database. If you already have one, you might want to integrate that to integrate your AWS resources with it. We also have our own AWS config, CMDB, which is a service we provide that tracks your resources over time. And finally, we have a service catalog, new service also that allow you to limit your users to starting specific pre-approved CloudFormation stacks. Logging and monitoring also critical. Again, we talked about CloudTrail. You also want to define your best practices for log collection, log aggregation, and log analysis. For example, you could decide to store all your logs into S3, a common solution, and to use Elastic MapReduce to analyze them, or to use Splunk to analyze them, but you want to define that upfront. And you might also want to integrate your security monitoring with AWS. Patching, it remains a lot the same as in-house. The difference is you need to, you have this new entity called AMI, Amazon Machine Image, that you want to include in the security parameter and patch regularly. And finally, penetration testing, denial of service. You can do this testing on Amazon. Okay, so now let's look with less detail at the rest of the operational processes. You will want to spend time in all of these categories. So how do we manage billing? So initially you do credit card billing, then you can transition to regular invoice, and probably you want to consolidate. If you start to have a lot of accounts, you want to consolidate them into one paying account. Asset management, we'll talk about CMDB in the context of security, but it's also important in the context of operations. Define best practices for high availability and resilience. So typically, for any application that has certain uptime requirements, you might want to enforce multi-AZ, multi-availability zone architecture. That's an example. Define how you're going to do backups in the cloud. Are you going to use the same tools you use today, like Symantec Net Backup, Backup Exec, which work fine in the cloud? Or are you going to use cloud-native functionalities like EBS snapshots, for example? How do you monitoring? So we'll have a slide on this, so I'm going to skip that for now. How are you going to manage change and configuration on AWS? You can probably replicate the same processes you have in-house. And finally, how do you automate and improve on release and deployment management and move towards being a DevOps shop with automated deployments? So in terms of monitoring, you could have, for your security, incidents and events management, you could have agents running on AWS and also use CloudTrail information or CloudWatch to populate that back into your on-premises security management system. For regular operations monitoring, you can use CloudWatch, which is built-in AWS. And you can also, in addition to CloudWatch, you can also deploy other monitoring solutions, such as open source Nagios or Zabbix, where you just install the agents on AWS and you can bring the information back in-house over your Direct Connect or your VPN. Microsoft System Center, we provide a management pack that you can download from AWS that allows you to monitor your EC2 instances from System Center and other software. Okay, So now that we looked at the operation processes things, let's look at some workloads that are common. So the first one is backup and archiving. It's very typical because it's easy. So it's a as a first project, it seems to it's pretty popular. It's very easy, and also S3 is a good platform for backups because it's very durable. S3 has 11 nines of durability. If there's one thing you don't want to do is lose your backups, so S3 is a good fit typically for backups. And typically you will store your newer backups on S3, and you move your older backups to Glacier after, let's say, 7 days, 14 days, or maybe a month. Glacier being about 3 times more cost efficient as S3. You can use our storage gateway. It has a virtual tape library mode, which means that the VTL compliant backup software, such as Symantec NetBackup, for example, will see it as a tape robot. So it will present itself as a tape robot to the backup software. So your backup software on premises will be able to write to the gateway as if it was a tape robot, and the storage gateway will then asynchronously move the data to S3. And when you eject the tape using the backup interface, the data will be moved from S3 to Glacier. Some backup software, I talked about Symantec before, like Oracle, Arman support S3 natively as a backup target. So that's a feature you can take advantage of. And we did that at Amazon a few years back. And not only we were able to reduce our capital expenditure by removing the entire backup infrastructure, but we were able to accelerate our restore times and reduce them from 15 to 2.5 hours, taking advantage of the bandwidth offered by S3. So again, we talked about the storage gateway that will look like this. And if you have multiple locations, it will look like that. Okay, moving on to a next stage would be disaster recovery, or DR. So just present 2 quick scenarios here, very easy. The first one is what we call the cold DR, which is kind of what we said so far. You send your backups to S3, let's say once a day. And if something happens, now you have your data in the cloud, and you have resources that you have computing that you can use to use that data. So typically in advance, you will prepare Amazon Machine Images for all your servers. So you start servers, you prepare your AMIs, you shut them down, so you stop paying for the compute time for these servers, just leave them there, maintain them. So if you update your software here, make sure you update it there also. And if something happens, then you're able to retrieve to restore from backup and then restart your environment. So while you might lose a lot of data, because if you send a backup once a day, you could have lost up to 24 hours of data. And while it might take a few hours to restore your database and restart your environment, it's a lot better than not having anything, right? So if you don't have a DR solution for some of your workloads, that's a really inexpensive way of having something. A bit better, or actually not better, maybe a bit more expensive, but also more efficient. Some companies, there's a very common use case. If you have, in this example, a 3-tier architecture with your information being mostly in your database, you implement replication from on-premises to AWS using Oracle Data Guard, Microsoft Always On, using Postgres or MySQL replication. And now you have your data, maybe you're a few minutes back here, but you have up-to-date data. If you have file systems, you want to do rsync also in addition to that. In this case, if something happens, you fail over, it will be, first, the failover will be quicker because your database is already running, you don't have to restore it from backup. But mostly, you will have lost very little data, which is very appealing in the case of a disaster. And some companies use this as a way, by the way, to migrate to AWS, where this becomes the primary, and then either this becomes the secondary for a while, or they set up a new secondary in a different AWS region. So we have a lot of references, a lot of customers doing this. This is Haven Power. It's a power company in the UK, sorry. So that's the architecture that they implemented. It's typical enterprise with SharePoint, with Exchange, SQL Server, Oracle databases. And they moved, that was one of their first workloads, or the first workloads they had. And typically when people do that, they start to understand and appreciate the flexibility of AWS, and then they started deploying other workloads on AWS. Dev and test. So it's also a very friendly workload to get started with, because first it's less risky than moving prod. If you move dev and test, the perceived risk or the actual risk is actually a lot less than moving production. So it's a good way to get started. The other thing is developers like to have resources very quickly. They don't want to wait for months or weeks before they get new resources. So on AWS, they can quickly start resources, do the development, their testing, and when they're done, they stop, right? So it's a way. That's actually how I discovered AWS. I was IT director for a company, and developers asked me for resources. I had to ask them to wait for a few weeks until I would purchase these resources. And the next morning, they had done it on AWS. So that's when I realized, it was in 2008, and that's when I realized I should look at this very closely. So moving on in a dev and test environment, continuous integration and deployment is very important these days for if you want to be agile and fast, right? So you can set up your entire environment on AWS. For example, you could run a Git repository on EC2. Your issue tracking software such as Jira or Bugzilla or any of these, you can run it on EC2. You can find in the AWS Marketplace, you can find Amazon Machine images for most of these. And actually, most of these are actually free because they're open source, except Jira. Same with Jenkins. We have Jenkins AMIs in the AWS Marketplace. So that's for your building and continuous integration software. And then you can deploy that on EC2, on Opsworks, on Beanstalk. We also are releasing new services in that area. So so for code commit is managed Git repository by Amazon. So we will be fully if you're already using Git, you will be fully compliant with the Git tools you're using today. I put an asterisk because it's not yet generally available. It's not yet, but it will be soon. So for source control, for continuous integration, we are about to release AWS Code Pipeline, which is going to orchestrate all your continuous integration processes, such as building and deploying. And finally, we already released a deployment service called AWS Code Deploy, which can deploy software from GitHub and from S3. And soon from code commit, we'll be able to deploy it both on EC2 and on on-premises servers, which allows you to do hybrid architectures in your development environment. That's an example we have here, where we have a customer using, in their case, Jenkins in-house for building their code and deploying it. And then Jenkins will move the code to S3, and then Code Deploy will take it from there to deploy the code inside of AWS and also on premises. That's an example of a hybrid CI. Testing, you can obviously test your code on AWS also. You can run your unit regression testing on AWS, A/B testing, so testing two flavors of your software. Actually, a lot of companies do that in production. Amazon.com being an example, where at some point you might see a page that looks one way, and another customer might see the same page that looks different, and we collect data on which one works better, and then we keep that one. Gaming companies use that all the time. So in this case, we mentioned it with test, but you can do it in prod also. And finally, load testing. Load testing is also a cloud-friendly workload because you might want to have a lot of servers, but not for a very long time. So you don't want to purchase all this capacity for just a few hours of usage, right? So you can do it here. And maybe some more interesting applications now. Resource-intensive applications tend to be interesting also. So cloud bursting is an example where you run something in-house and you're running out of capacity and you want to leverage the cloud for that purpose. It's not always feasible based on the application, but sometimes it is. An example is with NASA. They take pictures of Mars and then they process them back on Earth. And to process them, they use their own data center and also Amazon resources. So all this processing is coordinated by Amazon Simple Workflow. And you have deciders. Deciders are the processes that decide what task is to be done next, running both on AWS and in their own data center, and also workers, which are actually doing the task of processing these images, running both on in-house and on AWS. So my guess is when they run out of capacity here, they just use more capacity on AWS. So a good example of a hybrid workload for cloud bursting. Enterprise applications. So SAP HANA 1, if you want to test it on AWS, if you want to test SAP HANA 1, you can buy an appliance from some traditional on-premises vendor, and that's going to cost you quite a bit. Or you can test it. The cost of the software is 99 cents per hour. So it's really an easy way to test it without taking a risk. And then, moving further into the hybrid deployments, we have examples of customers doing hybrid HANA deployments. This one is for Kellogg's, where they deployed dev and test on AWS and production in-house. One of the reasons why they probably deployed in-house is they wanted to have instances with half a terabyte of RAM. We do not provide that today on AWS, so they couldn't do it on AWS. We also have customers that deploy production HANA on AWS, but obviously not with so much RAM on every single node. SharePoint, if you want to deploy SharePoint, it's resource intensive, so it means that you will need to buy a lot of hardware on premises. In the cloud, what is interesting is you can do it quick. You don't have to buy this equipment. And we automated the deployments of SharePoint in 6 steps using CloudFormation scripts. Running 6 scripts, you can have this entire environment deployed on AWS. Or if you want to have it easier, we also introduced a new service called Workdocs that is a document storage and sharing service that we use now also internally at AWS to share our documents. And in this case, it's it's even simpler. You can use Workdocs. You can enable Active Directory federation with your on-premises Active Directory through the AWS Directory Service connector, and you're ready to go. In the same spirit, we introduced a VDI solution on what's called Workdocs, which you can also deploy within your VPC and secure using your VPC. If you haven't heard sorry, did I say Workdocs? Workspaces, right? So it's a managed, backed up by us desktop in the cloud. And some interesting workloads that are like data warehousing, Internet of Things, big data. They are very interesting. I think a lot of people want to experiment with them. The trouble is experimenting with big data can be expensive if you really have a lot of data. So actually I had a customer like this where they went and experimented with Hadoop, right? But the price tag didn't tell me exactly, but it was in that range, right? The problem with this kind of bets is you cannot make many bets with that kind of price tag. You can make one. If it fails, you will be in trouble with your management probably, and you probably won't do it again. And what we want to enable on AWS is the ability to fail fast and cheaply, so you can try again as opposed to stop trying. So we have a number of services that can be used for this big data or data warehousing or IoT workloads, both for collecting, storing, and then analyzing the data. So some examples, a typical, if you don't have a data warehouse, you want to analyze your data, which very often people don't do because traditional vendors have sold very expensive data warehouse systems, typically appliances. I used to work for one of these vendors, actually for 2 of these vendors. And typically you're talking about large, significant investments. So what we see a lot of customers doing is moving the data to S3, either from on-premises or from AWS. If needed, they process the data to make it relational using Hadoop, using Amazon EMR. They store it in Redshift, and then Redshift is ODBC and JDBC compliant, so you can run a BI tool in front of it to get your reports. That's an example from a customer called Skill Pages, where they do exactly that. They generate data, store it on S3, transform it with EMR, put it back on S3, copy it into Redshift, and then analyze it either with Excel using ODBC or with Tableau to get nice reports. So I have a friend, he's an Israeli SA in Luxembourg, and he says we have two customers, the customers who use Redshift and those who will. That's his theory. His second theory is whenever a startup uses Redshift, they get acquired. And actually in Israel, we had a lot of startups last year that started to use Redshift, and they get acquired. It's a coincidence, of course, but or maybe, actually it's not always a coincidence. Maybe they were able to show the value of the data they had collected to their investors or to their acquirers. And actually this company, Skill Pages, which is a British company, they also got acquired shortly, a few months ago. Okay, so now I have a few minutes left. So how to migrate? So we talked about starting new applications in the cloud. That's easier. The hard part is how now do I migrate my on-premises application to AWS? And it's not easy, but there's a process that we can implement. So first we do what we call or you can do a cloud readiness assessment to look at your landscape. What applications do I have? What is maybe special or as in hard to move, like I'm running on a mainframe, I'm running on Unix, right, which doesn't run on EC2. And then start to look at some time frames. So we're going to, you want to assess all your applications. So have an inventory of them, then prioritize them, and we'll look at how we can do that, and then look at the migration options, and finally probably have some kind of project plan to move them relatively quickly. In terms of segmentation and prioritization, typically we would advise that you look at these 4 items. How critical is it to the business? How complex it is. Is it tightly coupled, loosely coupled? How hard is it basically to move to the cloud? How big is it? If it's very big, maybe it's a good candidate to move soon to start to take advantage of the cost savings. And finally, identify the disaster recovery aspect, the high availability aspects to determine the architecture on AWS. So you could, here we just kept 2 dimensions, business impact and complexity, and you could group them this way, right? So this is low business impact, low complexity. This is high business impact, high complexity. One possible path would be I start with easy and not critical. So my organization will improve their skills on AWS while dealing with stuff that are not too hard and that are not too critical. And then I could move to important business impact, but still easy. And then I know my skills get better. And when I say my skills, I mean the skills of all the employees of my company get better, and we learn a lot more, and we get more confident, more proficient on AWS. And then we start to do the hard stuff, starting with the non-critical, and then finally we do the critical stuff. That's just a proposal. I have a customer, he starts here. He said, I'm going to pick the hardest one to move, because if I can do that, I can prove to everybody that everything is doable. So that's more like a high-risk strategy that I would not necessarily advise, but that's a choice. So then you start having a methodology of how am I going to migrate my applications, plan, do the transition itself, and then run it on AWS. So these are some examples. So here we have an application. I can decide to do a rehosting or lift and shift. It runs on Linux or Windows. I just move it as is. Advantage, it's fast. We have customers migrating thousands of applications within a few months, right? It's fast. Disadvantage, it typically doesn't take advantage of the benefits of the cloud. So it's a mixed bag. Replatforming will be, I'm going to basically keep it the same mostly, but make some changes to take advantage of the low-hanging fruits. So for example, I run a commercial expensive load balancer today on premises. I'm going to move to use Amazon ELB to be more cost efficient. I use an expensive commercial relational database. I'm going to use Postgres or MySQL to cut my cost. So these kind of small changes that you make that will make it still fast, but also start to take advantage of the cloud. Repurchasing is like, oh, this is too hard. I'm not able to move this thing, so I'm going to buy a new off-the-shelf software that I deploy myself on EC2. Or what we see increasingly is I'm going to use a SaaS offering. And very often you will have SaaS vendors running on AWS, and I'm going to be able to do VPC peering with their solution directly on AWS. And the one we like as architects is refactoring, where you don't have to do that from the start. You try to maximize the benefits of the cloud by implementing auto-scaling, by maybe asking your developers to change the code to exploit all the flexibility, the agility of AWS. So what we see typically is if you rehost, it's minimum efforts. Benefits are not great. Typically, you don't take advantage of auto-scaling, of the flexibility of the pay-as-you-go, but it's easy. And then if you move to the right, then it's more work, but also more benefits. That's kind of the net of it. So migration tools, I'm almost done. I see you guys, we started late. I'm actually not late, we just started late. So we provide some tools. One is VM import exports. Steve is the next presenter, he's great, by the way. Yeah, I'll be almost done. So we have a VM import export tool that allows you to import and export VMware VMs and Microsoft Hyper-V VMs and Citrix Xen VMs to the cloud and back. We also have some add-ons or plugins that you can download from AWS from us that are free. So, for example, we have a plugin for VMware vCenter that allows you to click on an instance inside of your private cloud, say deploy to EC2, and bam. So underneath it uses the VM import service, but it's just a lot more user-friendly. We also have a similar add-on for Microsoft System Center, which also allows you to move your instances from an Hyper-V cloud to AWS. And finally, for monitoring, we also have another add-on for Microsoft System Center. There's also a big ecosystem of partners that help you to migrate. So this slide, you can find it on our website. If not, ask me. So I'm not going to go through all of them because otherwise Steve will talk at 6 p.m. tonight. We also have a white paper that's a shortened URL that details all these migration steps I just talked about with much more precision and details. Examples? Sorry, should I go back? Sure. The presentation is actually, yes, it's not in the cloud because I couldn't upload it from my hotel. The upload link was too slow, but it will be in the cloud shortly. So you can ask me. And I think we published this presentation, so I'm not sure. Okay, an example, because it's nice to tell you you can, but it's even better if I show you some people that have migrated. Netflix is a common example of people that have migrated all their infrastructure or most of their infrastructure to the cloud. This is an oil and gas company, so very traditional enterprise. They moved, very conventional workloads with Oracle, SQL Server, NetScaler, Active Directory, SharePoint. So they moved that to AWS. So it can be done, and you see quite a few servers too. Dow Jones, they moved about 40 data centers. They consolidated from 40 to 6, and so most of the workloads going to the cloud. Migrated 3,000 apps. So that's it. We went through our agenda. I hope it's not the end of the journey, but maybe the beginning for your migrations. Yep, I still have 141 left. So what I wanted to say, we talked about a lot about processes today. But again, my point is not that you should, spend 1.5 years on processes before you do anything, because the common saying in the agile world is speed of iteration beats quality of iteration. So just iterate, break it down in small pieces, and start doing start experimenting as you go. Don't wait 4 months before experimenting. And right from the beginning, you should do a proof of concept or a pilot project. So initially, your hybrid architecture might look like this, and then you might like what you see. It might look like that after a while. And what we see is, people use it more and more, and at some point it might be like this, and then you can really focus on your business and be agile. Thank you.